Okay, so I'll just start going through it. But
All right.
to just remind you guys, this was the notes that I put out, the properties of waves. This properties of waves notes is what I'm basically taking every single equation off of. So if you didn't get an opportunity to really watch this or look at this, you'll want to make sure you have that. All of these equations will be on the test given to you, so you will not have to remember them. And the circles, I already rearranged them for you. So if I ask you to find number of cycles, I actually gave you the equation for that. So all the equations will be on the test, and they're going to be up for every single problem that you guys do. But this is where I'm taking all of these from. So there's an equation for frequency, there's an equation for period, there's an equation for wave speed. There's actually two equations for wave speed, because speed can be found through distance divided by time, and speed can be found using frequency and wavelength. So the key on the math is figure out what you're given in the problem and what you need to find, and then see if one of those match that as far as the equations go, and then plug in the numbers you have. A couple of them are two-part problems. So if it is a two-part problem, you have to work through that as well. So this one gives us the frequency of 16 hertz, and we want to know the period. So this is the basic period equation. You have to remember what period is telling us. Period is telling us that it's the time it takes for one wave cycle. So the frequency tells us that there are 16 wave cycles in 1 second of time. So if you were to kind of mark out a second of time and say, okay, that's 1 second. That is telling us that frequency means there'd be 16 wave cycles completed in that second of time. Okay, so I don't know if I'll get 16 in here. Okay, there's 16. So what period is asking is, tell me the amount of time it takes for one full wave cycle, that small amount of time. That's why the number is usually a decimal. And so it's just a small portion of a second, usually in the tenths, hundredths, or thousandths of a second. So that is what we're looking at when we're looking at period. So with that said, the equation, since period is a time, the equation we use is time, or T, and they use a capital for this time since period is a time. So T equals 1 over frequency. That's the equation we're going to be using every single time. So it's really simple. You just take this and you say, okay, 1 over 16 hertz equals, now you can't leave it as the fraction because that's 1/16 of a second, we know that, but I also want to know what is the actual number, so you have to do the division. So just take your calculator and literally do 1 divided by 16, and that's going to give us, oops, can't see what I'm doing, that's going to give us a number of seconds. So it's going to be 0.0625 seconds. So it's a small amount because remember, it's a portion of a second. It's how much time it takes for one wave cycle. Okay, so all the ones that ask for period, just 1 over the number and divide it out and get a amount of seconds. It's a time. Okay, so the next one is the frequency of a stadium wave is 3 hertz and the wavelength is 15 meters. We want to know speed. So remember, wave speed has the 2 different equations. So it has an equation where we either need distance and time to find speed, or the other equation is where we need frequency and wavelength. Well, this one gives us 3 hertz, which is frequency, and 15 meters, which is wavelength. So in this case, we're going to use the second equation, which is speed equals frequency multiplied, oops, that's not a wavelength, there we go, multiplied by wavelength. And remember, the lambda sign, that's a Greek alphabet sign, means wavelength. So whenever you see that on the test in an equation, that's wavelength. Okay, so 3 hertz. So speed is going to be x meters per second. And I'll just do this too because we're going to need to remember that We have to write out our variables at times. So we're looking for x meters per second here, speed. Our frequency is 3 hertz, and our wavelength is 15 meters. So x meters per second, that's the S, equals the frequency, 3 hertz, times the wavelength, which is 15 meters. And all we have to do is multiply 15 times 3. So you might know that 15 minutes times 3 is 45 minutes. So we're just going to say 45. And a hertz times a meter is going to be a meters per second. Because remember, a hertz is a 1 over second. And a meter is a meter over 1. So if we multiply a 1 over a second times a meter over 1, you get a meter over a second, or meters per second. So that tells us that the speed of that wave was 45 meters per second. Okay, so that's the basic way to find it with frequency and wavelength. Sometimes though we don't get frequency and wavelength, we have to do it the other way. So on the next one, an ocean wave travels at 28 meters per second, so that's a speed. And there is 6, I believe that says 6. Is that what it says, 6, for all you that actually have it? Yeah, I think so. My printer is terrible. Between wave crests, what is the frequency? So now we're given a speed, a wavelength, and we're looking for frequency. So we're going to use the same base equation here. And if you looked at the circle, you might have noticed that speed is on top, frequency and wavelength are on bottom. So if we're looking for frequency, we're going to cover up the F and get speed divided by wavelength. So frequency equals speed divided by wavelength. And we have the same variables that we had before. We're just given different things. So we're given 28 meters per second. And our frequency is what we're looking for. That's going to be x hertz. And our wavelength is going to be 6 meters. So we're going to plug it into this equation, and we're going to say x hertz, frequency, what we're looking for, equals our speed, 28 meters per second, divided by 6 meters. And then you just divide. So 28 divided by 6, and we're going to get 4.6 repeating. So we're just going to say 4.6. I'll round it up to 7. We'll go 4.67, and it's hertz. That's what we're looking for there. Okay, yeah, are we good? Just as long as I read that the right way, the correct numbers. Okay, so the next one, what is the frequency? So we're looking for frequency of a wave traveling 185 meters per second. So that's a speed that has 675 cycles in 26 seconds. We also need to know the wavelength. So we're looking for frequency and wavelength. So here's the key. I always like to look at my different equations for frequency and the one for wavelength and find out, do I have enough information in the problem to solve for one of these? Most likely, if it's asking for both, I need to find one of them in order to get to the second thing. So I'm going to look, and I do know that my equation for frequency is number of wave cycles divided by time. So I could find it that way. Or I could also use this bottom one, but I don't have a wavelength yet. So I couldn't find frequency because I don't have wavelength. So it looks like I need to find frequency using number of cycles and time. And guess what? It gives me number of cycles and time. So I'm going to use that frequency equals number of cycles divided by time to solve for frequency first. And then I believe with that information, I can find wavelength because I'm given speed and I'll have frequency. Okay, so for the first one, to get frequency, we need frequency, number of cycles, and time. And so frequency is what we're looking for. That's the hertz. Number of cycles, 675 cycles. And since cycles is just it's just an object, it's not an actual unit, we just say cycles or psi, or sometimes I'll just say CYC. I'll abbreviate it, that's fine. But you can't just leave the number by itself, even though there's no unit for number of cycles, because numbers by itself don't really mean anything. And then we have a time of 26 seconds. So I need to find, using this frequency, so number of cycles is 675 cycles, dividing that by my time of 26 seconds. And then I'm just going to plug that into my calculator and get my frequency. So 675, I'm going to divide that by 26. That's going to give me 25.96 is my frequency. So that's hertz, but I'm not done. So I have my frequency, but it's asking me to also find my wavelength. So now, using what I know about my wavelength equations, there's not a basic wavelength equation for itself, because wavelength is just a measurement between two cycles. So if you remember, you could do crest to crest or trough to trough. So if I had two waves, my wavelength would just be this distance here. So there's not an equation to solve for it by itself, but it is part of this speed, frequency, and wavelength equation up here. So if I'm looking for wavelength, wavelength is speed divided by frequency. So my equation would look like this. That's a wavelength, that's a lambda. My handwriting's getting worse and worse because I'm not in school. So I'm going to use this equation here for the second one, but I'm going to use my frequency I just found. And then I'm also going to use my speed that I'm given in the problem. So in this case, I'm going to need, and I'll just put it down here, I'm going to need a wavelength, a speed, and a frequency. Wavelength is what I'm looking for, so it's going to be x meters. My speed is 185 meters per second. It gave it to me right there. And my frequency, I just found it, 25.96 hertz. Unfortunately, these aren't nice round numbers like I did on the first worksheet, but that's because I just changed all the numbers for the review. But for the test, I tried to make nice numbers that were easy. Okay, so in this case, I'm just going to plug it into this equation. X meters equals speed, 185 meters per second, divided by frequency, 25.96 hertz. And then I'm just going to plug it in. So my calculator, 185 divided by 25.96. That's going to give me 7.1. And I'm going to round the 6, or use the 6 to round the 2 up. Oops, what did I do? Anyways, there was a 2 there. So I'm going to round it to 7.13 meters. So now I have used all the information there to find both my wavelength and my frequency. So that would be like an example of a 2-part problem where you have to find one first to get to the next one. Oh, someone else is coming in. Hold on real quick. Okay. So there we go. Hi, Randy. I see you just came in. So we already started. We're on we just finished number 4, but this will be on it'll be recorded, and I will be putting it up on Canvas, so you can always go back and look how to do these last few if you didn't get it. Okay, so I'm gonna keep going with number 5. So number 5 says, what is the wavelength of a wave that travels 350 meters in 12 seconds with a frequency, does that say 2.5? Does anybody have it in front of them? Give me a thumbs up if it. Actually, I might have it. Hold on. Let me see. I have it. 2.5. So that is 2.5 hertz. A bad printer. Okay. So let me see here. So now that I have 2.5 hertz, that's my frequency. So what I need for wavelength is the same thing I needed in the last problem. If I have wavelength, to find it, I need a speed and a frequency. So I have to use this little circle and say wavelength equals speed divided by frequency. That's what I just did there. So I'm going to put that over there to remember that I need this stuff. I need a wavelength, a speed, and a frequency. So I am given a frequency of 2.5 hertz, so I'm good there. The issue is I do not have a speed. I am told that the wave is traveling a distance of 350 meters in 12 seconds. So if I remember my first equation, for speed, is speed equals distance divided by time. So in this problem, I'm going to actually have to solve for speed using distance divided by time first, then use that speed and the frequency to get wavelength. Okay, so we'll eventually get to wavelength once we solve for speed. So that second equation is the first equation is speed equals distance divided by time. That's the same way we found velocity at the beginning of the year, distance divided by time. So we're going to need a speed, a distance, and a time for the first part of the problem. The speed is what we're looking for. It's going to be in meters per second. Our distance given to us is 350 meters, and our time is 12 seconds. So we're going to use this equation here to solve that. So S, which is x meters per second, our speed, equals our distance on top, 350 meters. We're going to divide that by our time of 12 seconds. So that proves to us we get a meters per second, since nothing cancels, and that's what we need, a meters per second. So I'm plugging it into my calculator, and I'm going to just do 350. I'm going to divide that by 12. That's going to give me 29.16. So I'm going to round that up to 29.17 though, because they're repeating 6. And that's meters per second. So I just found the speed, but I'm not done, because ultimately the goal is to get wavelength. Okay, so we have to go back up to this equation to get wavelength, and we now have a speed and a frequency, so we can solve for it. So we're going to have a speed, a frequency, and a wavelength. So this speed is what we're using for here. And then the frequency that is given to us here is 2.5 hertz. And we're looking for wavelength, which is x meters. So I'm just going to plug that into this equation just as it is. So x meters, I don't have a lot of room, but I will make it work, equals speed on top, so 29.17 meters per second. And I'm going to divide that by the frequency, which is 2.5 hertz. Oops, that would be a Z, not an S. Hopefully you can read that. And I'm just going to divide. So 29.17, I'm going to divide that by 2.5. That's going to give me 11.66. And since I'm looking for meters, actually let's round up 7. So I took my 8 and used it to round up. And that is the wavelength of this wave. Oh. Andy's back. Okay, so there we go. So remember, stop me if you have questions, or if you're wanting me to clarify anything, that would be great. Okay, so the next one, now we're looking for how many wave cycles. So how many wave cycles are completed when a wave has a frequency of 68 hertz in 35 seconds. So we're given a time and we're given a frequency, and now I want to know number of cycles. Okay, so that would be back to this lovely equation, because I'm given frequency and time, I'm looking for number of cycles. So if I'm looking for number of cycles, I cover up number of cycles, and it shows me that I need to multiply frequency times time. So back to here. So my equation is going to look like this. Number of cycles equals frequency multiplied by time. So I'm going to just, for sake of continuing this process, write down my variables. So this is what I'm looking for. And remember, it doesn't have a unit. So in this case, it's just going to be X. And then later I'll add cycles to the end of it when I find the answer. Frequency is 68 hertz. And time is 35 seconds. So I'm going to plug it into this equation right here. So number of cycles is x equals 68 hertz, my frequency. I'm multiplying that by 35 seconds. 68 times 35 is what I'm going to plug into the calculator. It's going to be 2,380 cycles. So it's asking me for the number of cycles. So now I know how many cycles there are using that equation. Okay, so last couple. A sound wave. So we did the speed of sound lab, and hopefully if you did it, you were kind of getting an idea that the speed of sound is relatively the same as long as you stay at sea level. So we're kind of going to prove that right here. And hopefully if you remember, the speed of sound in the virtual sound lab was right around 343 meters per second. So somewhere in that 340 to 345 meters per second at sea level. And then as you go up in altitude, so as you go up in altitude, like up a mountain, there you go, the air gets thinner up there, the molecules are further apart, therefore sound travels slower. That's why when we did that speed of sound lab, we found that at the top of Mount Everest, the speed of sound was 308 meters per second, slower. So the less dense the material, the slower speed is. The more dense the material, so if I get into water or if I get into a solid where the molecules are tightly packed together really close, sound travels faster because it has to have those molecules to transfer the energy. So that's kind of a hint there because that is going to be some questions on the test about solids and liquids and gases and the speed of sound. But anyways, back to solving the math part of it, we're going to find the speed of sound with some numbers we're given. So what is the speed of sound? And don't let that trick you because really speed of sound is just wave speed. So we're just looking for speed. And the frequency is 85 hertz and the wavelength is 4 meters. Okay, so in this case, since we're looking for speed, we have two ways. Sorry, I'm zooming in a little. We have two ways again. Remember, we can do it with distance and time, or we can do it with frequency and wavelength. And in this case, we're given frequency and wavelength, so we're going to use that equation. So that's going to be the speed equals frequency multiplied by wavelength. So we're going to need a speed, a frequency, and a wavelength. And we're looking for the speed of sound in this case. But any wave, you can find its speed, but in this case, we're talking sound. Frequency is 85 hertz. And the length of the wave is, that's a terrible 8, is 4 meters. So we are going to use the speed equals frequency times wavelength here. And that is going to tell us the speed of sound. So speed is x meters per second times our frequency, or frequency times our wavelength, which is 4 meters. So 85 times 4 is what I'm going to be plugging into my calculator. And we will see we got to our speed of sound. So speed of sound at 340 meters per second, which sounds like it's very close to sea level. Okay, so we're gonna move on to the next one because if you read the last one, it says you will need the answer from the question above to do this. So it says a sound wave, well, we just found the speed of sound, okay? So a sound wave has a pitch of 290 hertz. Now don't let the word pitch scare you. It still hertz. Remember, pitch and frequency go hand in hand when we're talking about sound. So this is the frequency or the pitch of whatever sound you're hearing. So just as a reminder, a higher pitch would have a higher frequency, a lower pitch would have a lower frequency of waves. So the higher and closer together, so the closer together these waves are, or the shorter the wavelength, the higher the pitch of sound you'd hear. And then opposite goes. The lower the pitch, you would have a lower frequency. So that will also be on the test, so just note that. Okay, so we're gonna take what we found up here, and we're also gonna take the frequency, and we wanna find wavelength using all that information. So we're still stuck in this, this up here. Since we're finding wavelength, we're given a speed and a frequency. Okay, so we're gonna have wavelength equals speed divided by frequency. There we go. Okay, so wavelength equals speed divided by frequency. So let's write out our variables: speed, frequency, and wavelength. We just found the speed because it says we need that answer. So 340 meters per second, because we're talking about a sound wave. The frequency given, or the pitch, is 290 hertz. And the wavelength is what we're looking for, x meters. So plugging it into this equation here, x meters equals speed on top, 340 meters per second. And we're going to divide that by our frequency of 290 hertz. So 340 divided by 290. Oops. Go the other direction. Cancel. Oh, it's already plugged in. So we got 340. Oops. And we're going to divide that by 290. And that's going to give us 1.17 as our wavelength meters. So the length of that wavelength for the speed of sound is actually kind of long if you really think about it. 1.17 meters. That's just 17 centimeters over the size of one of those meter sticks we have in class. So pretty long wavelengths when we're talking sound. Okay, so with that said, again, if you popped in late for this, I will be posting it because it is recording. So I'll post it on Canvas for you to go back and look at it if you need any additional questions with the math, or you just want to go through it one more time. But for now too, if you have a specific question on the Quizlet, the vocabulary, the math, would be a great time to ask. Some things that I will just note that you should make sure you kind of know for the test is know the units that we use for all of these. So know that speed is going to be meters per second and that wavelength is going to be in meters. Okay. And then those other parts that were on the original worksheet, like amplitude, okay, know that we're going to measure amplitude in meters and that frequency is in hertz. So all of those you're going to need to know for the test. There's going to be a matching for that. You will also need to know the definitions. You'll have a matching with the definitions. So that's what that Quizlet's there for. Did you have a question, Tyler? No?
Going a little bit fast.
Okay. On the math?
So
if you need to go back, remember I'll put this recording up. I'll just do that right after we get off this. So if you have to go back, you can go and rewind and go back to a problem that I was solving and go through it a little bit slower. Or if you have a specific question on one because you're stuck, then you can ask me.
that is tomorrow.
Uh-oh, kind of lost you. You can type it in the chat too. If you can't, your microphone's kind of breaking up. Let me check the chat. I have a few chat people. Oh, what time will the test? Oh, Tyler, you're going kind of fast. I know, I understand I go a little bit fast, but that's why I record it. So you can go back in it. Because if I go too slow, some people only are hopping on here because they don't know how to do a couple of them. And then they're waiting a really long time. So I'll try to, like I said, post this as soon as I'm done. And then you can pause it as many times as you want to. Randy, the test will be Tomorrow it opens at 7 a.m. So it'll just be open at that time. And then it closes. I'm changing it. It was 6 o'clock, but I had a student that's moving and they will not be able to take it before 6. So I'm changing it to 8 p.m. So it's going to be open the entire day. The key is, though, you have to start taking it before the end time. So it gives you 1.5 hours. So you have 90 minutes to take the test, and you have to start it, though, before that 90 minutes, before 8 p.m. So if you want the full hour and a half, you're going to have to start it by 6:30 p.m. in order to have the full hour and a half. It should not take most people the whole hour and a half, but you have that amount of time. Tyler, with your test, you're going to have 2 hours to take it. So you'll have to start it before or by 6 p.m. to get the entire 2 hours of time.
Right. I'm usually up at 8 a.m. So.
Okay. So whenever, just that's the thing is, if once you get on it, it's going to automatically start counting down the time, and it will close at 8 p.m., which means it will just stop you wherever you're at. Kind of the bad thing about Canvas quizzes. Okay. Any other questions? No, whoops, reverse. So a couple other things just to note to study. Like I said before, understand how pitch and frequency work. So understand that as frequency goes up, pitch goes up, and as frequency goes down, pitch goes down. There will be like a little fill in the blank type question on that. Also know about frequency and wavelength. So that was on the virtual speed of sound. I'm going to flip this over really quickly and just do a quick little demonstration of that. So if I have a wave that looks like this and I have a wave that looks like this, we have a high frequency and then we have a low frequency. So this is the key here. We notice that as the frequency goes up, what happens to the wavelength? It goes down. And that was a question on the lab. And I think most of you understand that. As frequency goes up, wavelength, actually I'll use the lambda. Wavelength goes down. And then as frequency goes down, then the wavelength here, so notice it gets higher. So we have wavelength going up. So there was a question on there where I said, are they inversely or directly proportional? So remember, inversely proportional, inversely means if one goes up, the other goes down. Directly means if one goes up, the other goes up, or if one goes down, the other goes down. Okay, so in this case, this relationship is inversely proportional. So you'll have to know that for the test as well. So just remember that. You might get the concept, but do remember these words when we're talking proportional for wavelength and frequency. Okay. And I'm trying to think. Oh, also know, this was one a lot of people didn't do on their test. If you have like a slinky pushing or not on the test, the worksheet. If you have a slinky pushing the wavelength through it, this is a longitudinal wavelength, remember? So the energy moves to the right, and also the medium. So the medium is what the wave is traveling, is moving to the right. So they're moving parallel to each other. Okay, so this is what a sound wave travels like. It travels longitudinally. A lot of people forgot to measure the wavelength or show me the wavelength. Sorry, I put that up there. So if I ask you to tell me where the wavelength would be on this type of wave, a longitudinal wave, you have to start it at one position. And if I started at the beginning of the compression, so you can tell there's a compression here and a compression here. If I started at the beginning, the wavelength has to go to the beginning of the next wave. And so I didn't see that on everyone, so I just want to make sure everyone's ever clear of that. I could also start the wavelength at the back end of the compression, but then I'd have to go to the back end of the compression on this side too. So it's just like in transverse waves. Okay, I could go crest to crest. I could go trough to trough. That's a wavelength, that's a wavelength. I could pick the middle if I wanted to, as long as it's the same point on 2 consecutive waves. That's a wavelength. Okay, does that make sense, hopefully? So that was something I saw a lot of people didn't label on that, and it's kind of hard to label if you're doing it in Google Docs. So, okay, let me check the chat one more time. And I think that's mainly all the things I thought was important for you guys kind of know, unless you have your own questions. But again, vocabulary, units, know those, understand the math. Yeah, pretty much it.